Hello again and welcome to Chemistry, It Is All That Matters. And we're going to continue looking at ionic compounds, and now we're going to introduce the idea of polyatomic ions as part of that ionic compound. So a polyatomic ion is a non-metal molecule composed of two or more atoms bonded covalently, covalently meaning they're sharing electrons, not giving up or gaining electrons in order to become ions, but actually sharing their electrons. And in the sharing of those electrons, the molecule takes on either a positive or a negative charge. So we have some examples here of OH negative, which is called hydroxide, NO3 negative, which is nitrate, SO4 negative 2, which is sulfate, and PO4 negative 3, which is phosphate. And here we have an actual list of the most common ions we will use in this class. And this is available on a PDF here on the Sophia, but it's also available in your Blackboard in the toolkit, but also in Chapter 7. So there are also two positive polyatomic ions, and these are unique in that they are the only positive polyatomics. And remember, the word polyatomic means many atoms, poly, the prefix for many, atomic referring to atoms. So we're talking about a molecule made up of more than one atom. And in the case of ammonium, NH4, it's a positive 1 charge. And also you have hydronium, which is actually water with an extra hydrogen, and that too is a positive 1 charge. The rest of the polyatomic ions we will deal with, as you saw briefly on that chart, are all negatively charged ions. So how does this work? Well, in the case of calcium combining with hydroxide, the hydroxide is negative 1, calcium is positive 2, so in this case you need 2 of the hydroxide molecules. So we don't just simply put a 2 after the H, because that would mean 2 H's but only 1 O. We actually need 2 hydroxides. So we're going to put the hydroxide molecule in parentheses, and the subscript 2 tells us we have 2 hydroxide molecules with that 1 calcium atom. And this becomes calcium hydroxide. The metal retains its name, and the polyatomic ion is named by the molecules it carries, and those names will become more and more familiar to you as we go through the semester and you use your ion chart to put together these molecules. So here we have magnesium sulfate, and in this case magnesium is +2. The sulfate, SO4, is -2, so their charges are already equal and opposite, so they go together in a 1-to-1 ratio of MgSO4, magnesium sulfate. Let's look at another example, and we'll look at the positive polyatomic, and we're combining it with a negative polyatomic, and in this case we have ammonium phosphate going together. Ammonium is +1, phosphate is -3, so that would mean we need 3 of the ammonium molecules in order to balance the -3 from the phosphate. And remember, we're not simply putting a 3 after the H4, we're putting a 3 after the entire NH4 molecule, so that's why we put the molecule in parentheses, NH4 3 PO4, and this again is ammonium phosphate. So there are 2 PDFs available in the Sophia playlist, and I wish you would go ahead and print those out, fill them in, and then come back to see how you did. And the first one asks you to take the names and write out the formulas, and the second one gives you the formulas and asks you to write out the names. So once again, print those out, complete them, and then come back and check how you did. So let's see how we did. So the first molecule, magnesium nitrate, is Mg parentheses NO3 2. Knowing that Mg is plus 2 and NO3 is minus 1, we need 2 of the nitrates. PbSO4 2 because lead 4 sulfate, the Roman numeral 4 from the transition metals tells us that lead is plus 4, so we need 2 of the negative 2 sulfates to balance. Calcium phosphate comes out to Ca3PO4 2. Ammonium chloride, those are plus 1 and minus 1, they go together at a 1-to-1 ratio of NH4Cl. Sodium nitrite is Na2NO2. Sodium has plus 1, NO2 is negative 2, so you need 2 sodiums. Copper nitrate is CuNO3. Then you have iron sulfate, Fe2SO33. Potassium bromate is KBrO3. Sodium bisulfate is NaHSO4. Aluminum 2 sulfate 3, Al2SO43, and lead 2 nitrate is PbNO3 2. So let's move forward and look at the other direction. KMnO4 is potassium permanganate. NaC2H3O2 is sodium acetate. FeSO3, because the SO3 is minus 2, that means the iron here is plus 2, that's why it's iron 2 sulfite. Whereas FeIO3 3, IO3 is negative 1, but there are 3 of them making negative 3, so the iron is plus 3 in this case, therefore the Roman numeral 3. Magnesium sulfate, MgSO4. Ammonium sulfite, NH4 2SO3. Potassium chlorate, KClO3. Sodium hydroxide, silver nitrate, and calcium hydroxide. So as we've gone through, we see we have binary molecules of ionic compounds using a metal and a nonmetal. We then looked at the transition metals, where you could have more than one charge, and that charge is determined by the Roman numeral in the name. And then we have now looked at polyatomic ions as part of the ionic compound. So as you continue to learn this naming process of ionic molecules, just keep working on your chemistry.